I'm Christopher Nankervis, so I've got a company called Weather Logistics. So what we do is seasonal climate prediction, so looking at 2 to 15 weeks ahead. And with some STFC funding, I was working with Helen Cockerton at NIAB, so that's in Kent. And because they deal with fruit, so soft fruit and top fruit as well, there's a big opportunity for looking at how climate change impacts food waste. So also Peter Allen was working in our team as well, so he provided some mentoring and a bit of advice. But we're interested in how we can use machine learning techniques and the data science kind of elements to the STFC as well. So the slides were actually put together by Helen, who's not here today. So basically, she sent out a survey. So that was one component. So she sent it out to many different growers to see what their views were on climate change. And also, NIAB collected together all the data from their farms as well. So there were lots of different fruits data collection. That was in a pretty messy format. So at Weather Logistics, I took on an intern, and she actually did quite a lot of the data cleaning, getting that data into the right format. So I've got the results also from the tomato yield data, which we looked at from a tomato grower. So is this loud enough? So from the survey, we've got, we had 15 growers responded. So the growers were from lots of organisations, such as the fruit organisations, and also their growers as well. So the cooperatives sent that out. And we had some interaction on Twitter as well. And also, Helen got an article in Horticultural Week, and it also went out in the AHDB newsletter. So the general feedback was that people are quite mixed in their views of climate change. So basically, the scores range from 7 to 100 when they're asked whether they were concerned about climate change. Some people weren't concerned whatsoever. And the main concerns, in order of concern, is basically getting the right skilled workforce, is pretty much equal with extreme weather events, but also pesticide use as well, and the fact that some pesticides might be taken or pulled away. Some of the other questions identified quite clearly that using weather and climate prediction tools would be really, really useful in the industry. And some were willing to give data away, but not that many, unless it was anonymous, in which case it was about 2/3 of people. And some of the other results here, so people are currently implementing some climate mitigation as well as adaptation strategies, and some are LEAF accredited, so they have an accreditation that they're going to do something sustainable for the environment. Some of the written responses here were that basically everything about extreme, so extreme heat, extreme humidity, extreme temperatures, are their main concerns, rather than climate itself, the actual weather extreme impacts. So the pesticide study, we looked at quite a lot of data here at Weather Logistics, and we looked at aphids, powdery mildew, and scab. So these were contact applications of pesticides, so they were only applied when there was actually some signs of the disease. So by looking at these, we could actually see whether there was a link between climate, 5 minutes. So we're looking at whether there was a link between the climate on these seasonal timescales and the outbreaks of these based on those contact applications. I don't know what's happened here, but some of the data's just vanished. So there was difference from monthly hours. So we looked at monthly data and the departure from a monthly average, and the sunlight data, rainfall data as an accumulation, and the number of days of air frost. And on the bottom here, there should be some data on the sprays as well, which for some reason is not there, so I'll skip it. But there wasn't any link with that data, so there wasn't any strong association with the number of contact sprays for these certain pests and diseases and the climate. So in terms of the disease, obviously it's a complex system, so maybe it's just the fact that we're looking at individual months, not looking at the data in the right way. So that it's a bit more complex. So with the tomato data, we looked at about 6 years of data. So this was from one of the big tomato growers, and they grow indoors. And we were looking at outdoor temperatures as well as the sensor data indoors. And that actually showed that there was actually a link. So outdoor temperature, even though the tomato greenhouses were climate controlled, there was a link, and actually too much sunlight, it doesn't really make that much difference. So there's an optimum level in the middle. And also cumulative outdoor temperature, it peaks at a certain number of heating degree day units, so a certain amount of thermal units during that growing season. So there's promising kind of data there to actually look at the seasonal timescales and the extreme weather events that you see over those monthly timescales, and actually work with the Tomato Growers Association and also AHDB to get some kind of wider project there to actually do more work. And the AHDB are quite positive in actually going forwards with that kind of work with the wider benefit for their growers. So thank you for listening. Cheers.